Now let us see the next topic, enthalpy change of a reaction. Enthalpy change, energy change that is associated or heat content associated with a particular reaction. Now what is this? How is this represented? It is represented as delta HR, R for reaction. Okay. Now what is delta HR? It is equal to sum of the enthalpies of products minus sum of enthalpies of reactants. Now supposing this is your reaction, methane plus 2O2 gives CO2 plus 2H2O. This is the equation. Now once you start with thermodynamics, please remember children, you have to write the physical state of each and every substance. Okay, gas or liquid, you have to represent it as compulsory. Okay, this is very, very important. You will understand the importance in the foregoing topics. So this is equal to what? Delta HR is equal to sigma delta HP minus sigma delta HR. What is the sigma? Sigma shows summation, sum of enthalpies of products. What are the products? CO2 and water. And what are the reactants? CH4 and oxygen. Okay. So summation is denoted by the symbol sigma. Okay. Now what is this? You remove the sigma and detail the complete equation. Now how do you get? Delta HR is equal to, now on the product side, there is only one CO2. So I have written 1. First you have to take the coefficient of that particular substance into delta H formation of CO2 plus 2 into delta H formation of water. So this is your product minus 1 into CH4 is only 1 in number. So 1 into delta HF of CH4, that is heat of formation of CH4, plus 2 into delta H formation of oxygen. Okay, so this is delta H formation of each and every substance will be given to you. Okay, now based on that, you replace the values here and find out the answer for the numerical. Right, now let us see a little bit in detail and then you can come to the numerical part of it. Now what is this standard heat of formation? I told you standard heat of formation. It is all standard heat of formation. When you put a naught over the top, it is called standard. Standard conditions of temperature and pressure. What are the standard conditions of temperature and pressure in thermochemistry? It is 1 atmosphere and 25 degrees C. These are the two standard conditions. Okay. You are no more going to consider 0 degrees Celsius and 1 atmosphere. In thermodynamics, the standard conditions are 1 atmosphere and 25 degrees Celsius. Okay. Now, what is this delta H naught F? Delta H naught F is nothing but standard heat of formation. F for formation. Now, what is standard heat of formation? It is the heat of formation of any substance which is associated with the formation of 1 mole of that substance from its constituent elements in their standard states. Okay. Now, standard states. What do you mean by standard states? Each and every element exists in a particular natural state, is it not? That is called as standard state. And you have to mention the formation of that substance from its constituent elements in their standard states. Supposing you want to explain or you want to write the equation for standard heat of formation of water. Water is what? H2O. What is this H2O made up of? Hydrogen and oxygen. This you know it. Okay. So the elements which make up water are hydrogen and oxygen. Okay. Now this is the equation, how it has to be written. It is the formation of 1 mole of that substance. Only 1 mole. Is it not? 1 mole of the substance from its constituent elements. Constituent elements are hydrogen and oxygen. In their standard states, hydrogen exists in the form of gas. Oxygen also is existing in the form of gas. And here it should be only 1 mole. Otherwise, you may also write the equation as 2H2 plus O2 gives 2H2O. Is it not? Here you are showing 2 moles of water formation. But this is not the way to write for standard heat of formation of a substance. You have to show only 1 mole. That is why I have written 1 mole here. Now 1 mole ke corresponding half a mole of oxygen hi kafi hai. Only then it will balance the equation, is it not? So H2 plus half O2 gives water in the liquid state. All the subscripts are very important. Now supposing you want to give heat of formation of CO2, standard heat of formation of CO2. CO2 किससे बनता है? Carbon and oxygen. Which form of carbon? Graphite. Graphite is the naturally existing form of carbon, mostly. So you will write C graphite plus O2 gas gives CO2 gas. Now what is the heat energy associated with the formation of CO2? Each and every equation will be associated with some energy. Is that clear? इसमें मान लो 287 kilojoule of energy is released. इसमें 341 kilojoule of energy is released. Something like that it will come. All that will be given to you. You need not have to mug up all that. Then supposing you want to write standard heat of formation of ammonia. Ammonia, there is only 1 nitrogen and 3 hydrogen. Okay? So here 1 nitrogen means here you will write half N2 and there are only 3 hydrogen atoms, so you will write 1.5 H2. 1.5 into 2 will be 3, so it will be half nitrogen plus 3 by 2. 3 by 2 is 1.5, 3 by 2 H2 gives NH3. So this is called as heat of formation of ammonia, standard heat of formation of ammonia. Supposing you want to write for NaOH. NaOH is made up of Na, O and H. I told you formation of that substance from its constituent elements in their standard states. Na in the solid form plus half O2 in the gas form, half H2 in the gas form, that will give you NaOH. Is it not? Half H2 is 1, half O2 is 1, Na is 1. So NaOH. Same way HCl, half H2 plus half Cl2 gives HCl. Supposing you want to show the formation of glucose, then it is 6C graphite plus 6 H2 gas plus 3 O2 gas gives this. Okay, this has to be 1 mole. यहाँ पे जो मर्जी इसके हिसाब से जो होना है वो यहाँ पे हो सकता है, पर यहाँ पे only 1 mole should be there. Exactly, a formation should be only 1 mole of that substance. It may be using any number of moles of the constituent elements. Okay, but see that formation, that is product side, it should be only 1 mole in each of the reaction. And one more thing that you have to remember is standard heat of formation of any substance in its natural form of existence is 0. There is no heat of formation associated with any substance which is naturally existing. Like O2 is already there. Nobody is forming it. It's already there. So heat of formation of oxygen is 0. Same way hydrogen is there. So heat of formation of hydrogen is 0. Heat of formation of carbon in the graphite state, it is 0 because it's already existing. Same way, heat of formation of mercury in the liquid state is equal to 0. Right? Heat of formation of N2 gas is equal to 0. It is already existing in nature. Okay? So anything that is already existing in nature, it is not associated with any heat energy. So its value is taken as 0. This you have to remember whenever you write any equation. So here in this equation, when you write delta HF of CH4 plus 2 into delta HF of O2, here this will be 0. O2 is already naturally existing, so here the value will be 0, right?